So we've spent a lot of time looking at the unit circle where the radius is 1, but we can also evaluate the 6 trigonometric functions of an angle that is not on the unit circle. And pretty much the only thing that we're going to worry about is that it's going to change the length of the radius. We can always take any circle, no matter where it's centered, and shift it down to be centered at the origin. So we're going to assume that we're centered at the origin. But if the length of the radius changes, then we no longer have the same right triangle relationships as we did when the radius, aka the hypotenuse, was 1. And so we're just going to kind of briefly redefine our trig values. Remember that when we were on the unit circle, everywhere that there's an r here, the answer was 1. So that's why the sine of theta was only equal to the y-coordinate, because it's y over 1. So all we have to do is just take into account the fact that the radius might be something other than 1, which is why it becomes the denominator. And this just comes from your trig ratios. This is opposite over hypotenuse, adjacent over hypotenuse, and so on. And then your 3 reciprocal functions are just the reciprocals of sine, cosine, and tangent. Since we're looking at a right triangle, the way that we find the value of r is simply the Pythagorean theorem. R squared equals x squared plus y squared, and if you square root both sides, then you get square root of x squared plus y squared. One thing that's important to notice is that r is always going to be a positive value because it represents the distance from the origin. X and y are going to be values that represent a direction, and so they can be either positive or negative, but r will always be a positive number. So here is how we have to adjust our process a little bit if that is the case, okay? So we have the point P, which is -3, -5, and that's on the terminal side of angle theta. We want to find each of the trigonometric functions of theta. Notice they did not tell us that we were on the unit circle, so we never want to assume that that is the case. So there's a few different things that we need to decide. One, I always want to determine what quadrant I'm in. So if my x and y are both negative, we are in quadrant 3. That may or may not be important in this particular problem, but that is always something you want to be aware of with every single problem that you do. So we currently know that for our point x is equal to 3, or sorry, -3, and y is equal to -5. What we need to be able to answer this question is the value of r. And so the way that we're going to do that is r is equal to the square root of x squared plus y squared. So in this case, r is going to be equal to the square root of 34. And again, r is always positive. You don't need to worry about a plus or minus or anything like that. R is always going to be a positive value. So now that we have all 3 of those things, all we need to do is use those 6 rules from up above. So the sine of theta, and notice we don't actually know what theta is, we just know the ratio that we're going to figure out. So the sine is y over r, which would be -5 over the square root of 34, which we can then rationalize to be -5 root 34 over 34. The cosine of theta is going to be -3 over the square root of 34, which is -3 root 34 over 34. And the tangent does not change, like the length of the radius does not affect the tangent. And so it's y over x, just like it has always been, which is -5 over -3. Negative divided by negative is a positive, so we get 5/3. Now, when we go to do our reciprocal functions, we could choose to look here and flip this one over. But if it's equal to this value, that's what I want to work with, because if I flip that, I don't need to rationalize. So it's kind of one of those things, think smarter, not harder. So the reciprocal of sine is cosecant. The cosecant of theta, when I flip that over, will be negative square root 34 over 5. Secant theta is going to be the reciprocal of cosine, so that's going to be negative square root 34 over 3. And the cotangent of theta is going to be the reciprocal of 5/3, which is 3/5. And so there we go. We have all 3 of those. Let's look at something where you might have to set it up a little bit differently. Before we move on, as I mentioned, the quadrant that you are in is always going to be of crucial importance. And so the way that I remember the signs of the functions in each of the quadrants is all students take calculus. As you move around from quadrant 1 to quadrant 4, it's all students take calculus. And what that tells you, the A stands for all. Every single one of the 6 functions is positive in quadrant 1. The S stands for sine, and if it's true for sine, then it's also true for its reciprocal. T stands for tangent and cotangent, and C stands for cosine, and secant, its reciprocal. What this tells you, all students take calculus, it tells you which functions are positive. If it's not listed, it's negative. So the ASTC tells you which functions are positive in each quadrant, and then if it's not one of the ones that's listed, then that means it's negative. So if we want to determine the quadrant that an angle is in, we can use sort of a process of elimination here. So if they tell us that the tangent is negative and the cosine is positive, and we want to determine the quadrant in which theta lies. Well, if tangent is negative, that means it cannot be in quadrant 1 because everything is positive there. And then the tangent is positive in quadrant 3. Remember, all students take. So T is quadrant 3. That is where tangent is positive, so it cannot be there. So now we have to decide between quadrant 2 and 4. Based on the next piece of information, that the cosine of theta is greater than 0, we need the quadrant of those two where cosine is positive. All students, it is not positive in quadrant 2, take calculus. You are going to have a positive cosine in quadrant 4, so the answer is that theta lies in quadrant 4. Okay? So you can do any of those things here. Now, here's where it gets a little bit more involved. If we look at this next example here, they have told us that the tangent of theta is negative 1/3 and the cosine of theta is less than 0. We want to figure out the sine of theta and the secant of theta. So we need to start by determining what quadrant we are in. So if tangent is negative, again, it cannot be 1 or 3. But if cosine is negative, it cannot be 4. So this means that we are in quadrant 2. Why does that matter? Because in quadrant 2, ordered pairs have a negative x and a positive y. Since we know that the ratio for tangent is y over x, and what we currently have is negative 1/3, we need to decide where to put the negative. Does it go on the 1 or does it go on the 3? And since in quadrant 2, the x values are negative, that means we will need to make the 3 where the negative goes. We know negative 1/3 is negative 1/3 no matter where you put the negative, but when we're breaking this apart into individually what is y and what is x, the sign matters. So now we know that x is equal to negative 3, y is equal to positive 1, and r is going to be equal to the square root of negative 3 squared plus 1 squared, so you'll get the square root of 10. Now that we have that, we can figure out the values that we need. So sine of theta is y over r. So that'll be 1 over the square root of 10, which rationalizes to the square root of 10 over 10. Secant of theta is the reciprocal of cosine. Cosine is x over r. So for secant, we want r over x. And so we get negative 10, negative square root of 10/3 is your final answer there. So again, you need to start by determining the quadrant. That tells you the signs of x and y. And it depends on the ratio they give you. Both of these examples gave you tangent, but it might give you secant. It might give you sine. And so you just use the rule. If they give you sine, then you know you've been given y over r. R is always positive, so if there's a negative in that case, it has to go on the y. But you can always use your quadrant rules to determine the signs. And once you have that, you have everything you need to determine x, y, and r, and you can finish it out from there.